how do you know when a fraction will turn into a decimal that either repeats or terminates? So right now we're going to discuss looking at the fractions and without actually having to do the division and turn them into decimals, figuring out a method to help us see whether a fraction will become a terminating or a repeating decimal. Okay, so we're going to look at some of these examples here. For instance, 7/2. So many people can think in their head, oh, 7 divided by 2 is just 3.5. That's obviously a terminating decimal, okay? But let's look at some other fractions here. Let's look at numbers where 2 is the denominator, okay? So I want to just show you some ideas here. 1 divided by 2, 0.5. 2 divided by 2 would be 1. We're going to look at the patterns here to see if something divided by 2 always ends up being a terminating number. I'm seeing only terminating numbers. Would you agree? Oops. 7 divided by 2, that's the one we were on. 8 divided by 2. So you can see that we are seeing only terminating numbers here. Okay, so something with a denominator of 2 is going to terminate. Okay, so I'm going to put a T for terminate right here. What about 2/3? Again, a lot of people understand that 1/3 is 0.3 repeating, 2/3 is 0.6 repeating. So a lot of people at this point will be like, well, I already know that's repeating. I don't need to even think about that. But let's look at 3 as a denominator. Okay, 1/3 repeats. 2/3 repeats. I do want to point something out here on your calculator. Some people get confused because all of a sudden they throw a 7 at the end here. That's because your calculator, or in my case, my calculator, is rounding that last digit. So this really is 0.6 repeating forever and ever and ever and ever and ever. It's just that 7, they're saying, you know what, we don't have enough screen space here, so we're going to round up the last number for you. It should still be 66666 forever and ever and ever. It's just that the last number got rounded up to a 7. You might want to just kind of ignore the last digit that your calculator tells you if you know that it has exceeded the amount of space it can take up. Okay, obviously you don't want to ignore it if it's like 1/2. 0.5 is the correct answer there. But if it's a number that has multiple digits and you know that it's reached the end of its limit here, you might want to think just, kind of ignore that. 3 divided by 3. Okay, so here's a tricky one. The other ones were repeating, but 3 divided by 3, that's a terminating decimal. The reason is because 3 divided by 3 is not reduced all the way. One of the rules for this little trick here of figuring out if a fraction will be terminating or a repeating decimal is to make sure that the fraction is completely simplified. So 3 divided by 3 is really just the number 1. Okay, let's continue. 4 divided by 3, repeating. 5 divided by 3, repeating. See, it gave me the 7 at the end there. It did the same thing, by the way, on 4/3. It's just that the 3 isn't big enough to round up the last 3, whereas a 6 is big enough to round to the next number. 6 divided by 3, again, that's not a simplified fraction. That's just going to be 2. 7 divided by 3, repeating. 8 divided by 3, repeating. 9 divided by 3, wasn't simplified, it's just 3. 10 divided by 3, and so on and so on. So we can see when a number has a denominator of 3, it's going to end up being a repeating decimal, unless it's one of those tricky ones where, like we said, 9 divided by 3, 6 divided by 3, those ones aren't fully simplified. So you do have to watch and make sure that you're working with a fraction that is simplified as much as possible. Okay, so far, when the denominator is 2, the number will terminate. When the denominator is 3, it will repeat. What about a 4 as a denominator? 1/4 we know is 0.25, 25 hundredths. Okay, I know this one will terminate. Will all fractions terminate that have a denominator of 4? There's 1/4. 2/4, 3/4, 5/4. Oops, I skipped 4/4, but we know 4/4 is just 1. 6/4, 7/4. I'm only seeing terminating decimals here. So I think we can safely say that a denominator of 4 will give me a terminating decimal. Okay. A trick I had heard is that if you can take the denominator and multiply it up so that it is a 10 or 100 or 1,000 or 10,000, any number of, or any multiple of 10 basically, then it will for sure be a terminating decimal. So for instance, I could take 1/4, I'm gonna give a little example here, and multiply by 25/25 and change 1/4 to 25/100. If I can get it to scale up so that the denominator is 10 or 100 or 1000, basically any place value for a decimal, right? Because 25 over 100 would be 25 hundredths, 0.25. If I can make that happen, then of course it has to be a terminating decimal because it's going to terminate in the hundredth spot, okay? The same thing would happen here with 7 over 2. I can take 7 over 2 and multiply it by 5 over 5 so that I get 35 over 10, right? 35 over 10 will end in the tenths place, okay? So that's a neat little trick. And using that trick, we know that something divisible by 5 should be terminating because I know that I can get a 5 to turn into a 10 and 100 and 1,000 and 10,000, basically any multiple of 10, right? 3/5, I can take 3/5 and just multiply it by 2 over 2, and I get 6/10, which would be 0.6 repeating. So I know this is going to terminate, but let's just look at it anyway. 1/5, 1 divided by 5, 2/5, 3/5, 4/5, 6/5, and so on and so on. So we can see we're getting terminating decimals there. 5/6. Okay, very similar to 2/3. Will a denominator of 6 get me a repeating decimal or a terminating decimal? Let's check it out. 1/6 is repeating, 2/6 repeating, 3/6 that terminates. But again, 3 over 6, that wasn't reduced all the way, was it? 3/6 becomes 1/2. We already know 1/2 is 0.5. Now 2/6 also wasn't reduced all the way. 2/6 would change to 1/3, and that happens to be a repeating decimal anyway. So sometimes when you reduce it, it will end up being repeating anyway. Sometimes it'll end up being terminating, okay? So you just got to make sure that you're looking for the most reduced number here. 4/6, that's not reduced all the way. I could call that 2/3, but 2/3 is also going to be a repeating number. 5/6, repeating number. 6/6 isn't simplified all the way. We know it's just 1, so that one won't repeat. 7/6, 8/6, we're getting more and more. So as a in general rule, a denominator of 6 is going to be a repeating decimal, but you got to check and make sure that you're dealing with a simplified fraction all the way. Okay, for instance, 12/6 is not going to repeat, it'll be terminating because 12 over 6 is really just the number 2. What about 7? Will 7s repeat or terminate? Let's check. Whoops, I don't know why I start with 3 7s. Let's start with 1/7. Okay, so this one's a little tricky. 0.142857, and then it starts over again. 142, okay, that 9 seems to ruin it, but remember that last digit is being rounded up in your calculator, so let's just ignore it. Everything is following along the same pattern, right? 142, we get 142 over here. The next numbers will be 857. We just can't see that on the calculator, okay? 85, the calculator rounded up the 8 to a 9 because of that 5. That's why it's showing a 9 here. So again, you got to be careful about your calculator and that last digit. They will try to round it up. Let's see if that is the same for 2 7s. 0.2857, 2857. Look, we started over, 2857. Do you see how this time it didn't actually round up? Because the next number after the 7 is a 1, and 1 is not going to round 7 up to 8. How about 3 7s? 0.428571, 428. We're going to ignore the last one. 4 7s. So we're having a repeating decimal here, and it looks like it doesn't repeat to like the 6th or 7th digit. 1, 2, 3, 4, 5, 6. Yep, it goes 6 digits before it repeats itself again. So this is kind of an interesting repeat number. It's a long repeat number. 7142857, 714. That would be 2, and then the 85, except they rounded it. Yep, so 7 is going to be a repeating decimal. How about 8? Let's check. 1/8, terminating. 2 8s, terminating. 3 8s, 4 8s, 5 8s. Looks like we're dealing with terminating decimals here. Okay. And some of you might be thinking, wait, doesn't that mean that the 8 would need to be able to be scaled up to 10 or 100 or 1,000? And you are correct. 8, while I can't make 8 turn into a 10 or 100, I can make 8 turn into 1,000. I think I gotta check something on my calculator real quick though. The number I'd have to use to scale it up, okay, I was right, would be 125. If I multiply 3/8 by 125 times 125, I'm sorry, 125 over 125, I get 375 over 1,000. So because 8 is able to be scaled up to a power of 10, like 10 or 100 or 1,000, I know that it's going to be a terminating decimal. What about nines? Let's check the nines. 1/9, 2/9, 3/9, 4/9. You're probably seeing a really interesting pattern happening here. Okay, not only do we have repeating decimals, but look at the pattern. When it's 1/9, it's 0.1 repeating. When it's 2/9, it's 0.2 repeating. 3/9, 0.3 repeating. And remember, 3/9 is the same as 1/3. 4/9, 0.4 repeating. So let me just ask you, what do you think 8/9 is going to be? Yeah, 0.8 repeating. Now 9/9 is tricky because you would think, oh, it's going to be 0.9 repeating, but it's a number divided by itself. It's actually just going to end up being 1. And that is something that really throws people off sometimes if they stop to think about that too hard, because it should be 0.9999999 forever and ever and ever by one rule, right? The rule of the pattern here. But the other rule says if a number is divided by itself, it's always 1. Okay, it's kind of weird, huh? What happens if I go 10/9? Oh, a whole number, 0.1 repeating. 11/9? A whole number, 0.2 repeating. Very interesting, these nines. Okay, so a denominator of 9 will be a repeating decimal. 7/10, obviously that's going to be terminating. It's already a power of 10. 11, let's see what's happening with 11s here. 1/11, 2/11, 3/11, 4/11. So I'm seeing all terminating numbers here. And I want you to notice a cool little pattern with 11 as well, okay? Let's go back to just being able to see the 11s. So 1/11 got me 0.090909, so 09 repeating. 2/11, 0.1818181818. 3/11, 0.272727. Okay, so cool little trick here. If you take 3 times 9, you get 27. And when you do 3 divided by 11, you get 0.272727. 2 times 9 is 18. And when you do 2 divided by 11, you get 0.1818181818. For some reason, when the denominator is 11, it has to do with a multiple of 9. It's so weird. Look at 4 times 9 is 36. 4/11 is 0.363636. So using that same idea, what do you think 8/11 will be? Okay, so think, what's 8 times 9? 72. So 8/11 should be 0.72727272. Let's see if we're right. Look at that, 727272. So weird, huh? How about 6/11? 6 times 9 is 54. So 6/11 should be 0.545454. So weird, right? But 11 is a repeating decimal. We're going to quick just do 12, 13, 14, and 15. 12 is interesting because sometimes it'll be repeating and sometimes it'll be terminating. But in reality, it is a repeating denominator. And it only ends up being terminating because a lot of fractions can be reduced when they have a 12 as a denominator. So you're going to see here, if I do 1/12, that's repeating. 2/12, that's repeating. 3/12, though, is really 1/4, so it's going to terminate. 4/12, really 1/3, but it'll still be repeating. 5/12 ends up repeating. 6/12, remember, is really 1/2, so it's going to terminate. So be careful when you're dealing with 12 as a denominator, because you need to make sure that it's reduced all the way before you say, oh, I know it's going to be a repeating decimal. Just so you know, a 13, a 14, and a 15 are all repeating denominators. Okay, so these will all be repeating, but again, you have to make sure they are reduced all the way. Okay, for instance, if I was dealing with, let's see, 30/15. Okay, 30/15 is just the number 2. So watch out. Every denominator, you got to make sure that it's reduced all the way before you say, okay, definitely it's going to have a repeat. Okay, so what have we learned so far today? We learned, first of all, you always make sure that your fraction is as simplified as possible. Okay, always, always, always. Then we learned that certain denominators will always be terminating and certain denominators will always be repeating. Okay, so let's see. 1, we found, well, we didn't try 1, but anything over 1 is always just itself. So we know that 1 will be a terminating denominator. We learned that 2 is always a terminating denominator. We learned that 3 is always repeating. We learned 4 is terminating and that 5 is terminating. We learned that 6 is repeating, 7 is repeating, 8 is terminating, 9 is repeating, 10 is terminating, 11 and 12, and I ran out of room here, so 13, 14, and 15 are going to be repeating. Okay, so that is probably the quickest way I can explain how to decide whether a fraction will end up being a terminating or a repeating decimal without actually having to do the division problems. So if you kind of have these rules memorized, it ends up being a pretty quick, easy thing to just say, oh, this is terminating or this is repeating.